All right, so today we're going to do just a quick recap of all the different types of factoring, and then we'll talk a little bit more at the end about the newest one that we introduced last lesson. But let's just go through. So this is sort of the flow process, this is the thought process you should take. So step by step, this is what you should do. And first is you should always ask, is there a common factor that I can take out? And so if I'm looking at this, I'm looking at all three terms. And I have 2x squared, I have negative 6x, I have negative 20. There is not an x in each term, so I can't take out any x's. I can't factor out any x's. But I can divide each of these terms by 2. And so the way I think about that, and I'm going to just change the color here. The way I think about that is I can take out a 2 from there and from there and from there. And when I say take out, I really mean divide. So that's what I'm going to do. So I'm going to take out the 2, and I'm going to divide each term by 2, and just see what's left. So 2x squared divided by 2 is just x squared. Negative 6x divided by 2 is negative 3x. Negative 20 divided by 2 is negative 10. And so that's it. So I'm left with two factors. One of them is 2. That's one factor. And then the other factor is this large trinomial, because there's 1, 2, 3 terms. So that's a trinomial, but that's one factor, and this is the other factor. And again, when we say factors, we just mean these are two things that are multiplying. And if we multiply these together, we know we'll go right back there. That would be multiplication. Okay? Now, that's always step one. So the always, you're looking for that common factor. Is there something that I can take out no matter what the problem is? So just quickly look. If there is, do it. If not, fine. Now, sometimes you're going to take out that common factor and you're going to be done. But sometimes you're going to see, as in this case, you'll see that trinomial, and you might need to go a step further. So I'm going to write that example down again, what's just left. So right now we're just going to focus on this. So you'll have this x squared minus 3x minus 10, right? That is the factor we're going to focus on. And I'll have my 2 out there, but there's nothing we can do to the 2. What we're focusing on is this trinomial, okay? So is there a trinomial or a difference of perfect squares that I can factor? And right now we have a trinomial. We'll talk about the difference of perfect squares in the next example. Okay, so what we should know by now, the patterns that we should know by now is that the way we get a trinomial is by multiplying two binomials together, where you have x times x, that's where you get the x squared. And then what we need to find is, what are these two numbers here? What's the number that's going to go there, and what's the number that's going to go there? But we know two things about those numbers. One, we know that if we multiply them, they need to multiply to negative 10. So multiply to negative 10. And so that's where I'm always going to start. I'm going to figure out what number is going to multiply to get to negative 10. So I could multiply negative 1 times 10, and that would give me negative 10. But I know that these two numbers that I need also add to negative 3. Those are the two things that the pair of numbers I'm looking for need to do. And negative 1 plus 10 is positive 9. So that's not what I'm looking for. So let's try 5 and negative 2. So 5 times negative 2, that's negative 10. And if I add them, well, I get positive 3. So that's not going to work. But what I could do is I could flip the sign. So I could say, okay, how about a negative 5 and a positive 2? And sure enough, negative 5 times 2 is negative 10. So that works. And negative 5 plus 2 equals negative 3. So that works. So those are the two numbers. And so what that means is we're going to take those two numbers, negative 5, we'll pop that in on 1, and it doesn't matter which goes where, and the 2 we can take over here. But since it's negative 5, we just write minus 5, and since it's positive 2, we just write plus 2. And that's it. So these two terms, that binomial and that binomial, are what we get when we factor the trinomial. And then don't forget that we had that 2. So I'm just going to bring our 2 down as well from our original problem. And that is our complete. Okay, so let's take a quick detour to a difference of perfect squares, right? Because you could have gotten a situation where you didn't end up with a trinomial, you ended up with difference of perfect squares. So let's just do a quick recap of that. And so this is what we have. The situation here is we have two binomials, we have the same number, but different signs. One's plus, one's minus. And what's going to happen when we multiply these together is this middle term is going to drop out, and we'll see that. So x times x is x squared. X times negative 2 is negative 2x. And then when I distribute the positive 2, 2 times x is plus 2x. And 2 times negative 2 is minus 4. So right here, usually what we would end up with is a trinomial, but negative 2x and positive 2x cancel each other out. And I did not mean to erase that. I meant to cross that out. They cross each other out, and so what happens is you have your x squared, you have your minus 4, but you have no middle term, and the reason is because the numbers were the same and had different signs, so they cancel each other out. So you end up with this binomial term. You end up with 2 terms. But notice, x squared is a perfect square. It's x times x. And 4 is a perfect square. It's 2 times 2. And difference just means it was subtraction, right? That's what difference means. And so you have a difference of perfect squares. And so if anyone asks you to factor something that's like that, a difference of perfect squares, if you see this, oh, I have 2 terms, and x squared is a perfect square, and 4 is a perfect square, you can go, oh, that's a difference of perfect squares, as long as this is actually subtraction, right? It won't work if that's a plus. So you know that the way you got that was still by multiplying 2 binomials, but you know that it has to be the same number. You know that whatever goes there is going to be the same as there, but you're just going to have different signs. So what times itself is 4? That's 2 times 2.
This is mine.
Okay, so now we're getting into the more challenging problems. The other ones you probably have a good feel for now, but sometimes you're going to have a trinomial, and that leading coefficient is not 1. And there's a quick little difference we need to do at the beginning. So we're still going to end up with 2 binomials. We're still going to end up with something like, n plus 5, something like that. But we're not looking for 2 numbers that multiply to 15, right? This is what we need to do. We need to do 2 times 15. We need to multiply that 2 in the front by the 15. So, and that's 30. So we're look for 2 numbers that multiply not to 15, but to 30. So multiply to 30. Okay? And still add to negative 11. Okay? So we're still dealing with negative 11. We're still trying to add to negative 11, but it's not 15 times, this time it's 30. So if that leading term, that 2, is not a 1, multiply that by the 15. That's the key number that you're looking for. So let's just go through some numbers that multiply to 30. So I could do 2 times 15, right? And 2 times 15 would be 30, right? So that works. But 2 plus 15 is 17. That's not going to get me to negative 11, so that's not going to work. So what else could I do? I could do 6 and 5. Okay, so I could do 6 times 5, and that's 30. If I do 6 times 5, that's going to be positive 11. So I got the 11, but I need negative. So the positive's not going to work, but what if I do 2 negatives? Negative 6 times negative 5. When I multiply them, I get positive 30. But when I add them, negative 6 plus negative 5, I do get negative 11, which means those are the 2 numbers that we were looking for, negative 6 and negative 5. So I'm going to take those, and what I'm going to do here, is I'm going to split up that middle term using the ones that I just found. So instead of negative 11n, I'm going to write it like negative 6n. And negative 5n, because they were both negatives, okay? And then I'm just going to take down the 2n squared comes down, and the 15 is plus 15 comes down. But the key in that first step was splitting up that middle term. So if you have a situation where that leading number is not a 1, you're going to end up breaking up that middle term. And now what we do is something called factoring by grouping. We'll do another example on this in a second. But what I'm going to do is I'm going to look at my first group, these 2, and I'm going to look at my second group, these 2, separately. So for a second, I'm just going to look at those first 2, and I'm going to look for a common term. And I know I can divide each by 2, and I also can divide each by an n. So I can take out 2n there. So 2n squared divided by 2n is just going to be n, minus 6n divided by 2n is just 3. So it's n minus 3. Now I'm going to look at my next set, right? And if that number is a negative, so I'm going to take out the negative. I can take out negative 5. So I can divide each by negative 5. So negative 5n divided by negative 5 is just n. And then 15 divided by negative 5 is negative 3. So you just have to be careful with the signs there. Okay. But now notice we have these 2 blocks. and they're separated by that minus sign. And each of those blocks has a common factor. N plus 3 is a common factor. And so just like I was able to take out the 2, I can take out the n plus 3. So I'm going to do that. I'm going to take out the n minus 3. And what I'm going to be left with here is just a 2n minus the 5, right? Okay, so the factors that we end up with are n minus 3 is one factor and 2n minus 5. And so notice we didn't end up with just n and n. We ended up with n and a 2n, and that's because we started with this 2 here. But this is your solution. So now let's do one more of this factoring by grouping problem, where sometimes we're going to just start by factoring and grouping. We're not actually going to start with the trinomial. So it's a tool that you can use in a couple of different situations. So here's the situation right here. So right away, again, I don't have a trinomial. And there's nothing common to all of them. That's always my first step, right? I'm looking, okay, there's y squared, y. Well, there's no y in the 162, so I can't take out y's. I could take out an 81 on those second ones, but there's no, I can't divide, there's no number I can divide everything by. I have to be able to divide everything by. So now again, I'm going to do the same thing. I'm going to look at this group separately. And I can see that I can take out two y's from both, so I can take out y squared. And when I do that, y to the third divided by y squared is just y, plus 2y squared divided by y squared is just 2, okay? And then on the next term, I can divide each of those by 81. Remember, now I'm looking at this group. And if this is a negative, I'm always going to take out the negative 81. So negative 81. And when I do that, I'm going to have just y plus, because I'm dividing a negative by a negative. 162 divided by 81 is 2. And notice, you should see this pattern. This binomial that you take out should always end up being the same as that. Because now what we can do is we can take out this term from both sides. So that's going to come out from both. So I'm going to end up taking out the y plus 2. And then just like I do in other situations, I'm going to write in parentheses what's left. And what's left in this case is y squared minus 81. Now this is actually a really tricky problem that you might not have thought, oh, there's going to be another step. But look what this is. This right here is the difference of perfect squares. So remember, you're always looking for these certain patterns, and you got to just keep going until there's nothing else that you recognize that you can do. But so I know that this difference of perfect squares is going to be two binomials. I know I'll get y, and I know, okay, it's got to be different signs, plus and minus, and what times itself is 81? That's 9. So that's 9, and then the y plus 2 can't do anything, just bring it down, and that is completely factorized.